uh, 28 reasons to love the Sharp EL-W506T in your IEB and AP Maths classroom. So this is particularly directed towards IEB and AP Maths teachers. So if you are a normal maths teacher, that's also great, but we are going to do a little bit more in-depth stuff, including integrals and differentiation, because you are actually allowed in your normal maths classroom to use this calculator, which is quite cool. And then, of course, we'll cover things like matrices and complex numbers and integrals and differentiation and teaching annuities, which there is an awesome shortcut for. So it should take us about an hour or so to get through. And then if you do have any questions, pop them into the chat for me. Let me know what you're thinking or wondering. I will pause when I see a question come up as it fits in to my presentation here. But yeah, feel free to jump in with the chat function as well. So reason 29 is the home button, and I'll show you this as we go through various things. But just some important buttons: your change button, which will allow you to change the format of your answer, your mode button, your second function and alpha buttons, and I should actually mention the math button as well, which we'll use a little bit. So we have 9 different modes, which we'll go through, and of course the drill mode, which I'm not going to cover today because I am covering more grade 10 to 12 topics. But if you do have younger students, once you get your calculator, go and take a look at drill. It is absolutely awesome. It's so much fun to play with, and basically just allows you to practice your mental maths on the calculator. Then reason 31 is the simulator. So the simulator that I'm going to use now in this workshop is actually free to download. This is the link here where you can download it. Don't panic. What I will do is at the end of this workshop, I will put this presentation, I've actually saved it into a PDF for you, into the chat function. And then you can click on all of the links that I've given you here. So the first thing that I want to show you, if you haven't seen it before, is the teacher's class pass shortcut, which is really awesome. So we're in normal mode now, and what we're going to do is we're going to convert our test marks. And since it's exam term and test term and crazy term, this is a really nice shortcut to know. So the first thing that you do is you press your fraction button. In your numerator or the top of your fraction, you want to type in whatever you want to convert your marks to a total out. So if we are converting to percentages, for example, we would then type in 100. If we were converting to a smaller CAS mark, or so something out of 20 or 25 or 30, whatever you're going to use, then you would type that in the top. So I'm going to use 100 for percentages. And then at the bottom of your fraction in your denominator, you're going to type whatever the total that your test is out of. So let's say we set a test which was out of 70. Okay, press your right arrow key, say times, and then we're going to put our next student's mark in, which we'll say was 41. Okay, then we say equals, and we get 58 and 4/7, and we can change the way that that looks, and it gives us a decimal. I'll come back to that recurring in a little bit. It gives us a decimal answer of 58,57 or 59%. Now for your next student's mark, instead of having to type that whole thing in, all you would do is now type in the next mark. So the next student gets 23 out of 70. So we say 23, and then we just press equals. And now you've created a constant ratio. And then we can press change. And again, that's not recurring. Actually, I'll talk about recurring in a sec. So that will give you 32,85. So what's actually happening here is you have a setting that you can turn on, which is a recurring, sorry, I didn't press setup. So second function setup, and then press down, and you've got these 4 new options. So name, just, in fact, let me just do it. So what I did is last night I typed in my name, and you can just use your up and down arrow keys to select your letters and type in whatever you want. Let's see if I can make a smiley face. Do you think I can get it right? No, there's no brackets. there, we'll do an O. Okay, so if I do that and say equals, and then when I switch off my calculator, it will just display my name there. So you can't actually save any formulas or anything like that. It's just more of a ownership, cute, extra thing. Then, of course, your decimal points, you can have a dot or a comma, which is really cool. And then, of course, the recurring decimal, which I mentioned now, we'll just turn it on. So it comes standard with it off, but you can turn it on by pressing 1. And then, of course, we just say change. And now you'll see it will give you the recurring format of that decimal, so where the number is repeated. And then, of course, also your normal decimal as well. So back to the shortcut for class marks. So once you've typed in that first formula here, and you can just keep typing in your marks for your students, and it will just keep doing that constant for you. So instead of taking a long time to convert marks, it will take you all of 10 minutes. The coffee is still hot. You can spend time with your family and actually have a little bit of a life besides being a teacher. Okay, awesome, great. So let's go on to data handling now. So I'm going to show you. I'm not going to use this example because I don't type in 14 data points, but it works exactly the same way. So you can just follow this example if you're trying out stuff. So we're going to press mode and then 1 for stat, and we're going to choose 0 for SD, means single data, not standard deviation. I can see why that would be confusing. So I'm just going to make up some data values here and type them in. And there we go. Okay, so we've got all of those. Once we're happy with our data, so it's just type in your whatever your value is and press equals. Once you're happy typing them in, you press change. If you want to go back and edit your table or change anything, you can just press the change button to go back to your data. Then from here, what we're going to do is, let's say, for example, we weren't supposed to type in 14. We were supposed to type in 41. Okay, so what you do is highlight your 14 using your arrow keys, type in 41 over your 14 and press equals. And there you go. So now it's all changed and easy peasy. And then, of course, you can add extra data points if that's something that you wanted to do, if you were analyzing how additional things might change your average and standard deviation or spread of your data, and so on. Okay, so once you're done typing in your data, you can press change. And then to find your statistical values, you're going to press alpha and 8. And you can see in green above it, it says stat. So we'll just do that. So we have this menu, and the best option for this menu is just to press 0. And then what will happen is it will give you a summary of all of your statistical values. So your number of observations, wow, what a perfect average, 63 exactly with no dots, quite cool. No remainders. Your standard deviation, we use the sigma x because of the formula. And then, of course, your sum of x if you want to show your working out. And then your 5-number summary as well with your quartiles and your median. Thanks, Roselle. Yeah, stat mode is really awesome. It's a lot of fun. So that's everything there. Now, if you want to do a specific values, so for example, you wanted to find 1 standard deviation from the mean, then you could choose 2 for variable, choose your mean, and then say minus, and you can then go and find your standard deviation, which is 4, and there we go. So the bottom end of your data range within 1 standard deviation is 36.25, and then we can change that by using our BS means backspace, not what your kids write when they don't know the answer, and then plus and equals, and there's the top end of your 1 standard deviation of the mean. Okay. So that's single data. I want to show you linear regression at the same time. So I'm going to press 1 for stat, and this time I'll choose 1 for A plus BX, which is your linear regression line. Now, you can type in all of your X's, use your arrow keys, type in all of your Y's, but I often find that students make mistakes when they do that, because and also they're losing the point that the X and Y belongs together. Okay, it's a coordinate pair. It's not just random X's and random Y's next to each other. So the order matters. So what I like to do is type it in as a coordinate. So to do that, type in my X, then I press my X, Y button, and then I type in my Y and I say equals, and there we go. And let me put in 2 more coordinates. So it's your X, Y button, and then let's do that, and equals, and you can just see the calculator automatically puts it into your X and Y columns for you. And then let's just do 1 more. There we go. Okay, so obviously, as long as you have 2 coordinates, you can find a straight line, but it's always good to obviously have more. And in real life, I mean, or in any exam situation, you would obviously have a lot more than 3. I'm just doing 3 for time saving purposes. So once you're here, again, it's just pressing change to get to your calculation screen. You can just say alpha and 8. And then you've got this extra piece here, number 1, which we didn't have in single data. And if we press that 1, it will give us the regression equation line. So you can see my y-intercept is 1,66 or 1 2/3. My gradient, which is b, is 3,5, and my correlation coefficient is 0,99 because it's almost exactly a straight line. Obviously, the more points I would add, the more this would change, but it is a good indication, and it just shows you how easy it is to find the linear regression line. Then, of course, if you still need your stats or statistical values, it's just simply alpha 8 and choosing 0, and there's your summary again for both X and for Y as well. Cool. So that's statistics in a nutshell. It's pretty awesome. Very nice and easy to use. Oh, I forgot to mention the t-value, my bad. So what I want to do is go back to my single data table, and I'm just going to actually share both of these with you so that you can see what I'm doing. So here, I'm going to go back to one for stats, and this is for the AP Maths guys, if you are doing AP Maths. So you would use the t-value for probability and so on and so forth. So we're going to have 10, and then you're going to have a frequency because you're creating a normal distribution, right? So 10 and 5 equals, and then 20 and 12 equals, and then 30 and 18 equals, and then let's just go to the next one. There we go. And then we'll have 40. I'm just creating, the reason I'm doing so many points is so that you get a proper nice normal distribution graph here, so that your t-value is more accurate. And then 60 and 24 equals, 70 and 19 equals, and then 80 and 11 equals, and then 90 and 4 equals. So you can sort of see the pattern, or if we drew it in a histogram, you would see the little bump that it uses. Okay, so from there, then we have the 4 different types of where we can use the t-value for. So you've got the probability where your value is t or less. So finding all of that area there, when t is negative, all of that small area there. With Q, you're looking for the area between 0 and t, and for R, you're looking at the positive side of P. Okay, so I'm just going to do one example with you, and let me share again like that. So again, we've got, once you've typed in your data, you can just press change, and then for this we use our math button, and you'll see it gives you T, P, Q, and R, so you just choose what you like. So we'll use the probability of 67 is your t value or your x value. And then again, we'll press math and choose 0 for t. And then all we have to do is press equals, and it will give us the area under the curve. So, which is 0,8. So it's quite a nice way to do that as well. Okay, here's your linear regression example, which we went through as well. Then of course you also have a distribution mode. So again, if you're doing advanced statistics with your students for AP Maths, then you would be able to use the distribution, and you have an option of normal, binomial, and Poisson. And then of course you also have a PDF. In each of these, you have a probability density function, your cumulative density function, and then of course the inverse calculation for you as well. So it will calculate the area. So let me show you quickly. So we're going to go to mode, and we're going to choose 7 for distribution, and we're just going to use the normal, and we're going to do a normal probability density function. So we're just going to use 0 again. So your x is your x where you're working from now, right? So we're going to type in, let's say we get 2, and our average is 4, and our standard deviation is 0.5. So it's obviously not a standard Z probability density function or Z graph. And there, of course, is your answer for that. So the probability that x is equal to 67 within your data. So it's quite a nice handy function to have as well. Then, of course, we also have an unlimited table mode. Oh, are there any questions with regards to the density function or any of those things? I know it's a selective module, so I'm not sure if anyone is actually covering it, but if you are, that's it. Okay, cool, fantastic. Okay, so let me show you this, which is really cool. Awesome, thanks, Roselle. Okay, so we're going to go to our table mode. Now, table mode is my favorite, next to stats, of course. Is my favorite function on the calculator, simply from a teaching perspective, because it's just really a nice, yes, and for Cambridge, thanks, Roselle. It's a really nice way for teaching a lot of functions, and I'll show you that towards the end, where we'll talk about teaching an annuity and applying that annuity and being able to solve annuities quite nice and easily without all of the, or checking our answers from annuities as well. So let's just do finding factor pairs. So let's say we want the factor pairs of 36, so we type in 36, press our fraction button, press RCL twice to give us an X. So you can also say alpha and RCL, but I'm lazy, so I like the shortest possible way, which is pressing RCL twice. But up to you how you like to do it. I'm going to leave function 2 for now, but we'll come back to it later. I'm going to leave my start at 0 and my step at 1. And there's my, so anything divided by 0 is undefined, and you get this little stripy line, which is our asymptote. So we can see that whenever we have a stripy line in our graph, we know that we need to draw a stripy line on our actual graph, which is really nice. Not very confusing at all. Then we've got all of our factor pairs here. Okay. And you can see what's really nice is your table is completely unlimited. You can go for as long as you like without running out of space. And even though we started at 0, I went too far to make my point. Even though we started at 0, it doesn't matter because your graph is unlimited in either direction. So wherever you start from is a point of convenience for you, but you can choose. I mean, it's really quite nice because you can make your steps as small as you like and get a very accurate description of what's going on in your graph as well. So that's just really nice. Then of course we've added some new functions as well. So you've got prime factors. So if I press the home button, it'll just take me back to normal mode. Then if I want the prime factors of say 96, I type in 96, I press equals, and then I say second function and exp, and it will give me my prime factors. Then of course we've also added the lowest common multiple and the highest common factor function. So you can say, I want the highest common factor of 96 and 42. So I press second function and 2 to get GCD, which stands for greatest common divisor, which is the same thing as highest common factor. Then we'll type in 42 and we can say equals, and we can see that the answer is 6. So my common factor of 96 and 42 is 6. And what's really nice is you can do this with as many numbers. You can look for the highest common factor of as many numbers as you can fit into your table, which is like 300 and something characters. So you've got a lot of room. Obviously, I don't expect that we'll ever use that many. But it's nice to know that you have that option if you ever want to do it. So there we go. So we put in a whole bunch, and let's just add one more for fun. And there we go. So now we can see that out of all of those numbers, the highest common factor is 3. And we can do the same thing with lowest common multiple, but this time we press second function and 3. So there's our lowest common multiple. And again, you can do it with as many numbers as you like. It's as much as your screen can fit into that. What's really nice about lowest common multiple is that you can use it to teach fractions. So teaching them about the lowest common denominator, which is exactly the same thing, where you're looking for your lowest denominator in your fractions, and you can just use these, putting the denominators inside and then finding out what it would be and working from there. So it's a really nice application thing as well. Okay, then there's lots of nice time applications on the calculator as well. So what you can do is, if, for example, you had 470 minutes, and this is particularly nice for the math lit guys as well, you can just press DMS, and then we have 470, and you can say equals, and it gives us 7 hours and 50 minutes. And then, of course, we can also change that back into normal hour notation by pressing second function in DMS, and that gives us 7 and 5/6, and we can change that, of course, into a fraction or a decimal as well. Then you can also do it with seconds. So you can have 0 hours, DMS, 0 minutes, DMS, and let's say we have 300,500 seconds, and you press equals, and it gives us 83 hours, 28 minutes, and 20 seconds. So it breaks it down quite nicely for us. And of course, again, you can change it into a fraction if that's something that you wanted to do. Something else that's really nice is you can say, I have 58 hours. How many seconds do I have, or how many minutes is that? So I can just press 1 for seconds. There you go. Or I can say 2 for minutes, and it will give me that as well. Then the other nice application, which is nice for your science students when they do speed, distance, time calculations. So if I drive to Carnarvon, which is 760 kilometers away, and I do an average speed of 103 kilometers per hour, how long does it take me to get there? Well, it takes me 7 hours and something, 7 hours and 20 minutes, I'm guessing. So we can say second function and DMS, and it will give me 7 hours and 22 minutes and 43,107 seconds, obviously with no. So that's also a nice one. And then, of course, your last application is particularly handy for the math lit guys of your juniors, grade 8s and 9s. So if Susie gets on the train at 10:15, she gets off at 12:25. How long was she on the train for? When you type in 12, 25 minus 10:15 is 9:45, and equals, and it gives us 2 hours and 40 minutes. And we can say second function and DMS, and it will give us our fraction or decimal form of that as well. What's really nice here, I don't know if you saw, is you don't need to put in another one, even if you don't have seconds. So if you have seconds, obviously you need to put the DMS in, but your notation, it just assumes automatically that that's a minutes and that's an hours for you. So it's a really nice, easy way to use the calculator. Great, so that's time. Then we have this awesome shortcut. So if you haven't seen it, it's really cool. So remember when we teach trigonometry and we have a coordinate pair, we have 5 and 6. Sorry, that's a dot, not a 6. Okay, so sorry, 5 and 12. Let's just make it like that. And we're looking for our R and our theta. So what we can do is we can type in 5, then x comma y, and then 12. And then all we do is press second function and 8. And that gives us our R, which is 13, which is our hypotenuse there, and theta, which is this angle over here. So that's 67,38. What's really nice as well is you can also do it in reverse. So we could say my hypotenuse is 13 and my angle is 67.13. I'm making it up. And then we say second function and 9, and it will give us our x and y coordinates as well, or our units of length, depending on what kind of question we are answering. So that's a really nice one for Pythagoras. Then you've also got on the calculator a differential and an integration function as well. So let's do differentiation first. We're going to use the blue key, alpha, and your close bracket button. And we can then see, there we go, didn't press it properly. You can just type in whatever your expression is. So we could say 3x squared plus 2x, like so. And obviously it's finding the derivative at a point. So let's say our point is -1. And we can then say equals, and it will give us the gradient at that point where x is equal to -1. You can also do the integral, so you can find the area between any two points of the curve. So we'll just use the same one. Like so. So you just type in your expression. You can also use trigonometry. Obviously that would probably tend towards 0 depending on, oopsie, I see I've made a mistake here with my ends. There we go. Okay. I should have used my shortcut. So the shortcut is just to say second function and your left arrow key, and then that will take you right back to the beginning of something, which makes it a lot easier to edit something right in the front. And of course, you can also take it right back to the end as well by saying second function and your right arrow button. Once you've finished typing in your expression, you can just press equals. It will say busy in the top there as it works through the stuff. And of course, it gives us an answer of 0. Who would have guessed? So there we go. So that's the integration and differentiation function on the calculator as well. Then we do have complex numbers. I'm not going to dive too deeply into it because it's not covered in too much depth. So you just press mode and 3 for complex. And then you can see in the corner here, I've got X, Y. In other words, how I'm typing in things is in my rectangular format. And you'll see it breaks it into real and imaginary values. You can also then convert it into your polar coordinates by pressing the second function and 8. And that will give you your R, your hypotenuse, and then your angle that your arc makes as well. And then, of course, we can also type in an angle, and a hypotenuse, so we'll put 15, and use our angle, which is second function and x comma y, and let's call our angle 36 degrees, right? And then again, you can convert it back to your rectangular coordinates as well. Then, of course, you've also got the conjugate, so you could find the conjugate pair of anything, which is really nice to know. Although I feel like this is something that's quite straightforward for students, so they should be able to get it without using the calculator. But hey, it's there if you need it. So in the presentation, in the notes that I'm going to give you at the end, there's a very in-depth look at all of this. It's just basically what I've shown you. It also will give you, if you typed in anything, it could give you your real and imaginary values as well, which is quite nice to have. Then you also have an equation solver, which is pretty handy. So we press mode and 4 for equation, and you've got 2 a 2-variable linear equation and a 3-variable linear equation. Okay, so almost like basic matrices. And then, of course, you've got your quadratic equation and your cubic. So if we did, for example, a cubic equation, we could just say A is 1, B is -6, C is 7, and -9. I'm making it up, so we'll see if it works. So you can see this is actually, you've got 1 real answer and 2 non-real answers as well with your I over there. And then, of course, you can do any equation solving. So if we did 2-variable linear expressions or equations, then you have A, B, and C, which is your constant, and then you've got it for the second ones as well, and then it will solve it for you. Just go back here and put random values in. There we go, and then it will give you those. Okay, cool. So that's basically equations. It's very straightforward. Make sure you type it in with the right values and solve. It's basically linear graphs if you have two intersecting linear graphs as well. Then, of course, you're also able to convert between your degrees and radians. I'm going to go back home now. And you can see in the top mode of your screen is degrees. So if you want to convert from 30 degrees into radians, then all you would have to do is press second function and your decimal points, and it will give you radians. And to convert from radians, so let's say we have pi over 4, and you want it in degrees, then you can say second function decimal, and then second function decimal again to get to degrees. Okay, now there is a shorter way of doing this, and let me show you because it will save you a lot of time. If you press store and then you've got D1, D2, D3, these are your user-defined shortcut keys. So if I press store and D1, it will say storing D1 and select function. Now, if I'm using radians a lot, I can obviously save this conversion function into my D1 key. In degrees, so let's say I have 60 degrees and I now want radians, then instead of saying second function and decimal, I can just press D1 and then it will convert it back for me again, which is quite a nice shortcut to have. With your user-defined shortcut keys, obviously it's only a function that's already on the calculator and you cannot store a formula in that function. You can only basically store second function and another function behind that. Okay, so we have spoken about recurring decimals, so I'm going to just leave that on. I'll leave it as is. And then let's talk probability. So we've actually got a really cool random function, and to access it, we press second function and 7. Then you've got random, which is random decimals between 0 and 1 to 3 decimal places. Your dice is a random dice, so 1 to 6. Your coin is math coin. So instead of saying heads and tails, it's going to say zeros and ones. And then you have random integer, which works slightly differently in that you first have to input the two values that you want to generate random numbers between. So if, for example, we wanted to generate numbers like we were adding the sums of dice. So for example, our smallest sum would be 1 plus 1, which is 2, so we'll put 2 there, and our highest sum would be 6 plus 6, which is 12, so we'll type that in there, and then we just press equals and it will generate random sums. I'll put that in inverted commas of the dice for you on your calculator, which is really nice. Then you can also do it with the lottery. So I like to play the lottery with my students when I introduce probability to them. So I would say between 1 and 52, and they all write their lottery numbers down. They write down 6 numbers. They switch their piece of paper with the friends next to them, and then we go, okay, lottery number 1 is 40, and we write it down, and the next one is 43 and 15 and so on, and then we see if any students actually get anywhere close to the lottery numbers. I haven't had any students yet win the lottery, so there you go. It's quite unlikely to happen as well. But there's lots of nice things that you can do with your random function as well. Then this is a particularly nice one for your math lit students. So the percentages function is very intuitive and it works very straightforwardly. So if you wanted 30% of 120, could just say 120 of is times 30, and then second function and 1%, and it will automatically calculate that for you. If we wanted to say, okay, my original cost was 120, and I'm giving you a discount of 25%, then I can say second function and 1, and then my new value or my new total that I would pay is 90 Rand. Then, of course, you can also find out what your cost before VAT is, and we can just do that by saying divided by 115 and second function 1, and that will give us 260 Rand. So before I paid tax, that's what I was actually paying. So that's in a nutshell all of the percentages as well. Then, of course, we spoke about the user-defined keys and saving that shortcut, so I'm not going to repeat it again. Then, of course, we have the Pi button, which is a dedicated Pi button. So if you just press Pi, it will automatically do that. And you, of course, will just give you, if we press change, those values there, 3,14, blah, 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 your actual value of Pi to 9 decimal. Great. No questions? Everyone's happy? I feel like I talk too much. I suppose it is a presentation. And then, of course, we've got logs. So you've got your standard log, which is with base 10. And then you've also got your logs with a different base. So that's just second function and pi. And then you can type in any base that you want. I'll just put in 232 and say equals, and it will give me that. So that's also a really nice one to know is and use as well. Now I've done some application ones here because I think they're really awesome. But before I dive into teaching graphs, I just wanted to point out that GeoGebra is awesome, and it's a really nice for teaching graphs. If you have access to a computer lab, you can actually do a whole bunch of exercises with GeoGebra, which is really, really cool. Then, of course, if you want to actually draw the graphs by hand, then Worksheet Works has got graph paper, which is really nice. So you can download graph paper and obviously photocopy it. All of their stuff is free as well. So that's quite like it. Then if I go back to table mode now, okay, and I'm just doing a basic straight line graph, but the application, I mean, I created a function study guide for grade 10s where we use the same methodology for all of the functions. And it's really such a nice way to explain what those values in your equation or your expression are actually doing for your graph. So let's come back here. So what we're going to do is just type in an x. So in other words, you have y is equal to x. And if I go through my table, I can see those are my coordinates. So if x is -3, y is -3. So it's exactly the same. But what happens if we do something to the x? So I'm going to leave x in function 1. And in function 2, I'm going to multiply my x by 2. Okay. And now what happens to my y? Well, my y doubles my previous one. Okay, so in other words, my y is 2 times as big as my x. Now, I would get the students to draw the graph, right? So we'd have a graph here. And then my y is equal to x graph would look like that. And then my y is equal to 2x graph would look something like that. Okay, so we would actually get the students to physically go and draw the graph and look at it. Then we can say, okay, so what happens if instead of 2x, I have -2x? What happens to my graph then? Well, if I go and look at my coordinates, you can now see that they have all changed into negative coordinates. So if I draw the graph now, let me just change colors quickly. And it will now look like that. And I've actually gone and drawn the graph for you so you can see using GeoGebra because it's lovely. So we can see there's my original y is equal to x graph. There's my y is equal to 2x graph. And there's my y is equal to -2x graph. And you can see it's an exact reflection about your y-axis as well. Then, of course, we can also do the same thing where we shift the graph up, we shift the graph down, and you can see the coordinates there as well. And if I draw the graph, the the gradients is exactly the same as my original graph. I've just moved all of my coordinates up 1 or down by 1, depending on which graph I am drawing. Then, of course, we can also use the calculator to teach simple and compound interest. So if you haven't seen this, if you have seen this, please forgive me. If you haven't, it's awesome. So I'm going to put in my simple interest formula, and I'm just going to use 10%. I'm not going to do any weird and wonderful things, but you can use it to teach compounding intervals, which is really cool, which is why I put my interest in a fraction format. Times x, and close brackets, and equals. And then in function 2, I'm going to put in my compound interest. Now, normally I would just start with simple interest and work through that, and then add the compound interest afterwards. But in the interests of weekend, I'm going to shorten it slightly. So of course, it's just putting in your compound interest formula as well. Okay, so we've got a simple interest formula, compound interest formula, and we can start at 0 and our step is 1. So our steps are obviously the number of years. So at 0, this is our initial investment. After 1 year, they've both earned 100 Rand. After 2 years, my simple interest has earned another 100 Rand. And if I go down the table, I can see I just keep adding 10% of 1,000, which is 100 Rand, right? Every time, doesn't change. But if I look at my compound interest, it is changing, because now instead of adding 10% of my original investment, I've added 10% of my previous year's investment. And if I go down, I can see it's 10% of that year's investment and 10% and so on. So my money is growing a lot faster than my simple interest money. So that's the gist of it. But what's really great here is because your table is unlimited, you can go and ask great questions like, how much money do you have after 10 years? When does your simple interest double? When does your compound interest double? Compound interest is doubled after 8 years. My simple interest took 10 years. When does my compound interest value double my simple interest value after how many years? So then I would go through and look for where the value is twice as much, which is approximately between 18 and 19 years. So it's a really nice, sure, look at the difference, just by compounding very simple. So it's a really nice way to show students the difference between simple and compound interest and the effects that it has. Then, of course, before I move on to that, you can also teach compounding intervals. I do want to go back to that. So what I'm going to do is I'm going to just delete that. Oh dear, let me put in a compounding interval. So let's say still the same interest, but this time I'm going to compound it monthly, right? So I'm going to have times 12. And then what we'll do is with my x, obviously I'm also going to multiply by 12 so that I've got the same comparison units. Okay, so I'm going to leave this original compound interest in there, which is non-compounding. And then you can see again, so after 1 year, that's my original amount. But here you can see that it's being compounded monthly. So it's added an additional 4 Rand to that amount on top of the original 100 Rand that was added. Here you can see you've already added an extra 10 Rand. And after 3 years, an extra 17 Rand and so on. So you can really see the difference that a compounding interval makes on your compound in general, compound annually versus compounded monthly total values as well. So that's that one. Now what I want to show you is a really nice way of dealing with specific trigonometry solutions. So when we're doing a general and specific equation in trig, so I have done this one. I don't want to do the whole simplifying of it with you. I assume that you're okay with that. But I do want to show you something really awesome. So we found our general solutions, which are these two here. Then what we'll do is in our table mode, let me just share this here with you so that you can see what I'm actually getting from here. So in my table mode, in my first, I'm going to just put this original general solution. So it's 10.53 times, and then I'm going to have x times 360, obviously because we don't have a K option on the calculator. So that's just going to be it. Oopsie, I was not supposed to say times, I was supposed to say plus. Okay, that looks better, and equals. And then in my function 2, I'm going to put my other general solution, so 130.53 plus x times 360. That's right. Okay, equals. Again, so you're going to leave your starts and step at 0 and 1. And basically what x is now is that K substitution. So we were looking for values between 30 and 200, right? So if I go back here and I now look, I've got that's too small, it's less than 30 degrees. So I've got 130.53, and that's too big because it's over 200 degrees. So my only specific solution for this question is actually 130.53. But you can see it's quite easy to substitute in your K's, and then you don't have all of that confusion that students generally experience with the mix-ups and the solutions, and then they can't find which one it is. It's quite easy to just go to the table and say, okay, those values fall within the range that I'm looking at. So it's a really nice way. I like it. I just discovered it this year, so I'm quite excited about it. Cool. So that's that. Then let me show you very quickly this teaching annuities thing, which is awesome. And then we'll do matrices. So I know it looks like a ginormous formula. So we're still in table mode. And I'm just going to put this here so you can sort of follow where I'm going, right? So in function 1, I'm going to put in an X for my payments. Okay, so this is a present value annuity. You can do this with a future value annuity as well, but it's nice to see what's actually going on here. So I'm going to type in an X, then I've got open brackets 1 minus open brackets 1 plus, and then we've got 10 over 100 times 12 because it's monthly, and then close brackets to the power of -5. So this means that we are borrowing over 5 years and we're paying it back monthly. Okay, and close the brackets, and then we've got 10 over 100 times 12. Okay, so that's my present value annuity formula that I've put in there. Okay, now I don't have a present value in mind specifically, and I want to show you why. So let's just delete that one. So we're going to leave function 2 blank. I'm going to leave my step at X just because I want to make my step at 1 because I want to make a point. So now, if I'm willing to pay back 1 Rand a month over 5 years, I can borrow 47 Rand at 10% interest compounded monthly. If I'm willing to pay back 3 Rand a month, I can borrow 140 Rand. So this would take a long time before we got anywhere significant. So what we can do is we can say, go back to our step and change it to, let's say, 100 Rand a month. Okay. So now we're incrementing in 100 Rand. So if I can pay back 100 Rand a month over 5 years at 10% compounded monthly, I can borrow 4,700 Rand. If I'm willing to pay back 1,000 Rand a month, I can now borrow 47,000 Rand. If I'm willing to pay back 2,500 Rand, then I can borrow 117 Rand. So it's a really nice way to explain how present values work and also how people's affordability is calculated. So if you want to buy a car for 100,000 Rand, you need to expect to be able to pay 2,200 Rand a month approximately for that car. Now, what's also really cool, and it came up in a discussion somewhere else, is you can actually work out what your monthly repayments would be if you were given a specific amount. So let's say, for example, we want to pay off 250,000, right? Okay, so we're going to say minus. So all I've done is I've taken the present value in my formula to the other side, basically, okay? Well, I've taken this to the other side with the present value, and I'm looking for the points in my answer where it's equal to 0, or as close to 0 as I can get, because that will give me an approximation. I'm going to leave my steps at 100 again, and what we're looking for is point where our answer is 0. That will tell us our monthly repayments on 250,000 rand. So I'm just going to scroll through. You see, this is what makes an unlimited table so nice, because now we can really use it for applying things like present value and stuff. So we can see it's quite a high amount that we would have to pay back. There we go. So it's approximately 5,300 rand. So what we can then do is go back to our start and type in 5,300, and this time we can make our step 10s. So now you'll get a really good approximation. So it's between 5,310 rand and 5,320. So should we guess, or shall we try and change that again? So let's make it, we'll just leave that there and just make our steps 5. And then we can go and look. So it's about 5,315 rand a month to borrow 250,000 rand at 10% per annum, compounded monthly. So it's a really nice application for present values. And of course, again, you can apply this to your future values as well. Just, it makes me happy. Okay, I'm going to stop now. The last thing that I want to show you is the matrices function. And this is particularly for the AP Maths guys. So bear with me if you're not AP Maths, but just look how fun it is. So we are going to use 5 matrices. And then the first thing that you need to do is to create a matrix. So press Math and we choose 1 for edit. Okay, and then you can choose how big you want to make your matrix. So you have an option of 2 by 2 up to 4 by 4. So it can be 2 by 4 or 2 by 3 or whatever. So I'm just going to leave it as a 2 by 2 because it's quite standard. And then we'll just put in some numbers here. Right. When you are done editing your matrix and you've put in all of your values, then you need to press on and press Math and choose 3 for store. And then we'll store it into matrix A. Now, if you're doing a lot of work with matrices, what I would recommend is actually storing your matrix name into your user-defined keys. So we'll just go to 0 and choose matrix A. So now, instead of going Math, matrix like that, we can just press D1 and then it comes up really quickly. So it saves a lot of time and frustration as well. So that's just squaring the matrix. If we wanted the inverse of the matrix, then we could just say, I've just got to find my inverse fraction. There it is. And voila, that's it. That's how easy it is to find the inverse of a matrix on the calculator. And then, of course, if you want your determinant, you have that's number 4 over there. So you could just say the determinant of matrix A, and there we go. And of course, we've also got your ref and RRF, which is row echelon form and reduced row echelon form. So if I did A, so that's my memory key A, and I press D1, then I have, there you go. So you can see it's actually been put into. Now this is better when your matrix is not a 2 by 2 because then you're actually solving for something. So you could actually add an additional column onto your matrix if you wanted to, and then solve for your X and Y like that as well. So that's, in a nutshell, very briefly, the matrices on the calculator. I just want to see if I wanted to share anything else with you for matrices. Of course, you can also get the transpose of a matrix, which is quite a common thing as well. So if we said Math and 5 for transpose, and then your matrix A and equals. And of course, you can add the matrices together. So if you stored into A and stored into B, you could add the 2 of them together. So we could do like that. You can multiply your matrices, so you can have 6 times matrix and so on. So it's very intuitive, very straightforward, very easy to use for matrices. And in fact, I use the older version of this calculator in my own applied maths exams. It made a huge difference. So it's nice to know, and particularly if they're going to go to university and study maths. So this was in applied maths that we did matrices in first year, calculus and other maths stuff. So this is a really nice functionality for doing reduced row. This comes up a lot, and it will save a lot of time to be able to check your answers on the calculator as well. All right, great. Then the last thing the last two things that I want to share with you is the Sharpies Teacher Reward Program, and that is for teachers like you who are willing to sit on your Friday afternoons and enjoy a webinar with me. Hopefully you enjoyed it. And so you can join the Sharpies Rewards Teacher Program. You get points for attending webinars like today's webinar. So if you are a Sharpies, yay for you. Then once you have enough points, you can exchange them for laptop bags and earphones. And of course, you can also if you change your stationery list, so you love the W506 so much that you want to use it in your classroom, then you can just send me a picture of your new updated stationery list and I will give you 200 points for changing it, which is pretty cool. And then of course you can also share and tell your friends about maths, the Sharpies Rewards Program, and that also gets you points as well. Then finally, we also have lots of free downloads and resources. So if you aren't aware, you can download the 535 simulator as well. The 506 link is at the beginning of the presentation, which I'll share with you in a jiff. And then of course, Maths Sharp has got grade 8 to 12, free maths worksheets, math worksheets, a couple of technical maths worksheets. Then the other nice one for us in FET mostly is the Math Warehouse worksheets. And then I've also created my own personal blog called themathsjourney.com, which mostly at the moment has grade 7 worksheets, but I'm building up to it. Awesome. Thank you guys so much for your time. I hope that you found today useful. For those of you who have joined us on YouTube, please subscribe. And if you have any questions, leave a comment down below.